Welcome, this is Sarunan, Assistant Professor, Department of AI&DS, working in KIT, Kannada Institute of Technology, going to take the subject Decision Analysis of Algorithm. Topic is Backtracking nQueen's problem. So backtracking is a more intelligent variation of this approach to construct the solutions one component at a time and evaluate each partially constructed candidates as follows. So many problems are difficult to solve algorithmically. The backtracking makes it possible to solve at least some large instances of difficult combinatorial problems. Suppose we have to make a series of decisions among the various choices where we do not have enough information to know what to choose. Each decision leads to a new set of choices. Some sequence of choices, more than one choices, may be a solution to your problem. So here the terminology is the problem statement is each node in the depth first search tree. We are going to solve the problem in the depth first search tree only. The state space is a set of all the paths from the root node to other nodes. The solution states are the problem states S for which the path from the root node to S. The answer states are that solution states S for which the path from root node to S defines a tuple that is a member of a set of solutions. Here the state space tree is a tree organizations of the solution space. Live node is currently generating node for which all the children has not been generated yet. E node is a live node whose children are currently expanding the node. Dead node is generated node that cannot be expanded any further. Okay. Applications of backtracking is nQueen's problem, sum of subset problem, graph coloring problem, then Hamiltonian cycle problems. First we are going to discuss the nQueen's problem. So the nQueen's problem is to place nQueen's on n-cross in chessboard so that no two queens attack each other by being in the same row or in the same column or in the same diagonal. So there is 3 steps only, that no two queens attack each other by being in the same row or the same column or the same diagonal. Consider the 4x4 chessboard. So in the 4x4 chessboard we have to place the 4 queens so that we follow the conditions like no two queens attack each other by being the same row or in the same column or in the same diagonal. We have to place the nQueen's problem. If the placed on the path marked by the dot lines, then they can attack each other. So this is the 2 queens problem we can solve very easily. The 2 queens problem is not solvable because we cannot see the same row is become illegal, same column also illegal, same diagonal also illegal. So there is no possibility to solve the 2 queens problem. Then we have to solve the nQueen's problem. So note that no 2 queens can attack each other. How to solve the nQueen's problem? Let us take the 4 queens problem, 4x4 chessboard. Place Q1 in the first possible position of the row on the first row and the second on the first column. Then place the Q2 after trying unsuccessful searches. So here we cannot place, here also place. So third position I am going to place this. So place 1, 2, 2, 1, 2, 2, then 2, 3. This is a dead end because we cannot place the another queens. Either we can, suppose we are placing here means here also queen having, we can also place here. So that is a dead end. So we have to use the backtracking concept here. So backtracking concept nothing but I am going to move the second column here. I am going to move this queen as a second column. Then again I am going to try the place the queens. So I can place the queen here, third one, but fourth one I cannot be placed because there is a dead end. So that we can choose the another possibility to place the nQueen's problem. So this is the final solutions. First I have placed the 1 to 3rd position. It is example for the nQueen's problem. It is example for the nQueen's problem. So I can place the Q1 here. So we can in the same row there is no queens to attack each other. So Q1, then Q2, Q3, Q4, Q5, Q6, Q7, Q8. This is the 8 queens problem here. So algorithm for the 8 queens problem. So function, this is a function. First problem descriptions, algorithms for implementing the nQueen's problems. Total input is total number of queens here. We can be either 4 or 8 or 16 or 32. So we have to place the rows comma column. The function will check the 2 queens are the same row, same diagonal or not. Here the row plus 1 is nothing but we can move each and every row should satisfy the conditions here. If row equal to n means there is a dead end. It is not possible to move the nQueen's problem, so it will print the value here. Then place the rows and comma column. Here only we are going to place the rows and columns. It will check the if board of I equal to column nothing but it will check either the two queens are the same row or the same diagonal. It will check. So the algorithm mainly for placing the queens at appropriate positions. Input rows and columns of the chessboard. Output returns 0 of completing the row and column position. There is no conflict. The algorithm check this board I equal to column nothing but it will check the same column by the two queens. So this is a formula. It gives the two queens on the same diagonal. If AB is nothing but absolute value, board I minus column equal to absolute value of I minus row. It will check the two queens are on the same diagonal. Consider the nQueen's problem for feasible sequence 6471. We have to place this 6471 in the chessboard. Remaining we can place any other values. So the feasible solutions to place the nQueen's problem. So these are the feasible solutions. I have placed a 6 4 7 1 7 1. Remaining I can place here 3, then 5, then 2, and last 8. Okay, this is the example for the nQueen's problem to place the feasible solutions. Thank you.